Okay. So in this lesson, we're going to take a closer look at one of the interesting chapters in mathematics, and this chapter is circle geometry. So I'm going to explain one or two concepts within this chapter, and I'm going to do so by means of an example that I've extracted from one of the past examination papers. So this question, as you see here, we've got a circle with so many lines that we have here. We've got line AT and line TB as the tangents. Remember what exactly a tangent is. A tangent is basically a line. This one is a line that touches the circle at what we call a point of contact. So here B is the point of contact and T here is the point of contact. So the angle ABC is given, that is 38 degrees, and also here we have the diameter where O is the center of the circle. Most of the students, they tend to panic when they see questions of this form, but what I can assure you, whenever you see a question of this form, relax. Try to recall the concepts that you have learned under the chapter for circle geometry. Okay, so you need to categorize, to group your theorems. They've got those theorems that have got something to do with the center. What are those theorems? There's that theorem which says angle subtended by an arc at the center is twice the angle subtended by that same arc at the circumference. There's also a theorem that says if you have a diameter, the angle subtended by a diameter is a right angle. And so many other theorems that mostly we love these ones. And also on tangents, also know that where a circle, where a tangent meet the radius, they form a 90-degree angle. You also need to think of the tan chord theorem. The angle between the tangent and the chord is equal to the angle subtended by that chord in the alternate segment. You also need to think of the tangents that are drawn from a common point, that those tangents that are drawn from a common point are equal. When it comes to the cyclic quadrilateral, you also need to know that a cyclic quadrilateral, this is a four-sided shape whose four vertices are on the circumference. So this angle, the opposite angles, they are supplementary, they add up to 180, right? And you also need to know that if you have a cyclic quadrilateral, right? Let's say you've got a cyclic quadrilateral, the exterior angle of a cyclic quadrilateral is equal to the opposite interior angle. So yes, put these theorems among these groups. Theorems that have got something to do with the center, theorems for the tangent, and theorems for the cyclic quadrilateral. So as you see this diagram, immediately you realize that, oh, there is a center. So since there is a center, which theorem do you need to think of? You need to think of that theorem which says angle subtended by the arc at the center is twice the angle subtended by the same arc at the circumference. So in this case, we have the center and we have a diameter, but there's also a theorem within that center that says angle subtended by a diameter is a right angle. So since this is a diameter, the angle subtended by that diameter here is a right angle. So straight away, we know that this angle is 90 degrees. Okay, so what do we have to do next? So straight away, we can calculate this angle. Why? Because we know that angles in a triangle, let's take for example, we have a triangle here. So angles in a triangle add up to 180. If you take angle A and add with angle B and add with angle C, you get 180 degrees. So in this case, if we say 180, let's say we want to calculate angle ACB or angle BCA. So what is going to be angle BCA, this angle? We know that angles in a triangle add up to 180, so it's going to be 180 minus 90 minus this angle minus 38. And what do we get? So if you say 180 degrees minus 90 degrees, you get 90 degrees. 90 degrees minus 98, you get something like 52 degrees. So yes, this angle is 52 degrees. Okay, so that's all as far as the center is concerned. But what else do you have? Remember, I said put your theorems into three main categories: theorems that affect the center, theorems that have got something to do with the tangent, and theorems that have got something to do with the cyclic quadrilateral. Another thing that you can see here, we have tangents. And what do we know about tangents? There's a theorem which says whenever a tangent meets with the radius, they do form a right angled triangle. So straight away, we know that not a right angle triangle, I mean they form a right angle, which is a 90-degree angle. So here we have a 90-degree angle because this is a tangent and this is a radius. So we know that a tangent and a radius, they meet at 90 degrees. So if this angle is 90 degrees, straight away we can also figure out this other angle, right? Because we know that this angle and this angle, they are complementary, they add up to 90 degrees. So if you want to find out this angle, what is this angle? It's angle ABT, right? Let's try to figure out this angle A, B, and then we turn to T. So how are we going to calculate that angle? So we're going to say 90 degrees minus 88 degrees. Straight away we still get 52 degrees. We could have calculated this angle using the tan chord theorem. Remember, the tan chord theorem specifies that the angle between a tangent, right, and a chord is equal to the angle subtended by that chord in the alternate segment. So obviously, if you look at this chord and this tangent, so the angle between this tangent and this chord is this one that we are calculating, right? They said it's equal to the angle subtended by this chord in the alternate segment. So if this angle is 52, this angle is 52. But remember, we've also got 52 using another concept. So either we could have used that concept for 90 minus 38, or we could have used that tan chord theorem. Whichever way, we can still get that this angle is 52 degrees. This is quite interesting. Okay, which other concept do we have to think of as far as the tangents are concerned? So we've applied the tan chord theorem, tan perpendicular rad. What about the tangents that are drawn from a common point? What does the rule say as far as those tangents are concerned? So as you see here, we've got tangent AT, we also have tangent TB. So we know that these tangents, since they're drawn from a common point, therefore they are equal in length. So what do we know about a shape like this? We call this an isosceles triangle. Okay, what is an isosceles triangle? You see that these sides are equal. So in an isosceles triangle, the base angles are also equal. So the angles opposite equal sides. So this side and this side are equal. So the angle opposite to this side is this one, and the angle opposite to this side is this one. So we know that opposite angles gives opposite equal sides. So equal sides, they give us opposite equal angles. Okay, so basically this angle and this angle are equal. So obviously if this side and this side are equal, the angle opposite to this side is this one, and the angle opposite to this side is this one. So these angles, they are equal. Therefore, this is also 52 degrees. Quite interesting. So how are we going to get this angle? Which angle is that? The one that we have for part B here. What is angle ATB? Imagine you're at A, you're moving to T, and at B at T, then you turn all the way to B. What is this angle? Remember, with this angle, we have this angle. Now we want to figure out this angle. And we know that angles in a triangle add up to 180 degrees. So straight away, 180 minus 52 will be the result for angle ATB. So this is 180 minus 52 minus 52, we get minus 104. So if you say 180 minus 104, straight away we get 76 degrees. So yes, this angle is 76 degrees. That's how we tackle questions that involves circle theorems. Awesome. If you have any other question for circle theorems that is bothering you, bring it on the table, then we do it together.